The third lecture of ATS 113's second unit is about moisture in the atmosphere, and it's going to come from two sections of the book, pages 66 and 67, and then at 121 through 132. The first two pages up here are about latent heat. Now, this is a complicated concept for a lot of students. It has to do with energy that is absorbed or released by water as it freezes or melts or evaporates or condenses. We're going to spend a lot of time on this in the class, but make sure you understand this concept by the end of the lecture of latent heat. This little diagram up here at the top of the page might be helpful to you. There's actually a better one on the course CD, so you might want to get that. I also think that this is an important little did you know type box down here, so make sure you understand what's going on. There's also either a flash animation or a video or something on your course CD about what's going on in that text box. Okay, then we jump ahead to page 121, which is in the moisture unit of the course textbook. It's actually the beginning of chapter 5. Alright, now on page 123 is the beginning of the information about the hydrologic cycle. We probably won't talk about the hydrologic cycle in class because probably most people learned a lot about this in a high school class. So you are responsible for the material about the hydrologic cycle, but we probably won't take time in the class. We'll spend the time better on things that students are less comfortable with. So make sure you read the section though on the hydrologic cycle. It will be on the test. So it just continues down here through the bottom of page 24. There's a nice little summary diagram here at the top of page 124. Alright, then we start learning about different ways to describe the amount of liquid water in the atmosphere and how the atmosphere can become saturated. This little thought experiment that they're doing at the bottom of page 125 is very important. We're going to draw the same diagram. We're going to learn about the factors that control the rate of evaporation from the water in the container to the atmosphere. This is going to be a very important concept explaining what it means for an air parcel to be saturated, so make sure you understand that diagram. The key concept that we're going to use to describe the amount of water vapor in the atmosphere is going to be vapor pressure, as illustrated here in the bottom left corner of page 126. Vapor pressure is going to be describing the amount of water vapor that's in the atmosphere, and this concept of saturation vapor pressure is going to be describing how much water vapor the air could hold. What controls principally the saturation vapor pressure of the air is the temperature. This diagram at the top of page 127 is incredibly important. I don't think your book uses the term, but this is an equation of this is a graph of the equation known as the Clausius-Clapeyron Equation. We'll use that term in class, but this is a very important. Notice how saturation vapor pressure depends very strongly on temperature. There are other measures of the amount of moisture that's in the air, and we will talk about them, and they will be important, like absolute humidity and specific humidity, and mixing ratio, and relative humidity. Relative humidity, of course, being the measure you most often hear on television during the weather forecast, so we're going to spend quite a bit of time talking about relative humidity as well. In fact, that's what this diagram down here at the bottom of 129 is trying to show in a somewhat clumsy way, how relative humidity is related to temperature as well as to the amount of moisture in the atmosphere. We'll actually describe this probably better than the way the textbook is, but that's an important figure. Once you've heard the lecture, make sure you understand what's going on in this figure. And then probably the granddaddy of them all, dew point. Dew point is a way of expressing the amount of water vapor that's in the air right now, and it's actually a temperature. It's how cold you would need to chill the air to reach saturation, and we're going to discuss this at length in class. This text box at the top of page 131 is probably not terribly important, and go just to where it begins with the set distribution of water vapor on page 132. All right, let me know if you have any questions. This has been Dr. John Truggy, copyright 2006.